A massive star in the galaxy next door spent 10 million years burning. Then, in 2014, it flickered. By 2023, it was just gone. No supernova, no fireworks, no light show that anyone on Earth or in orbit ever saw. Just gone. And in the spot where it used to be, astronomers think there is now a brand new black hole, born without the death scream every other massive star delivers. This is the story of M31-2014-DS1, the star that forgot how to die properly. Here is the rule the universe is supposed to follow. A massive star, anything more than about 8 times the mass of the Sun, burns through its fuel fast. 10 million years, give or take. Fast on a cosmic timescale. Then the core runs out of fuel, gravity wins, and the core collapses. The collapse fires a shock wave outward. The shock wave blasts the outer layers off into space. What is left behind is either a neutron star or a black hole. The blast itself is a Type II supernova, bright enough for a few weeks to outshine the entire galaxy it sits in. This is textbook physics. Baud and Zwicky proposed the mechanism in 1934. Every astronomy class teaches it. Massive stars explode. That is the rule. We have talked on this channel about iron 60, the atoms that supernovae blast across the galaxy and that eventually land in Antarctic ice. Those atoms come from stars that did explode. This video is about the ones that didn't, because here is the seam in the rule. Theorists have suspected for decades that not every massive star manages the explosion part. The energy budget is tight. If the shock wave doesn't push hard enough on the outer envelope, the envelope just falls back in. No light show. The star quietly disappears, and a black hole is left behind in its place. The technical name is direct collapse, or a failed supernova. And the math is more than theoretical. Astronomers have a problem with the count. Tally the massive stars that should be exploding against the supernovae we actually see. And the numbers don't match. Somewhere between 16 and 30% of massive stars seem to vanish without a recorded explosion. This is called the red-supergiant problem. The leading explanation: they are not vanishing. They are going dark quietly. Which means every galaxy in the observable universe is full of stealth black holes nobody saw form, including this one. For decades, the red supergiant problem has been a statistical hole. The strongest individual candidate, a star called N6946BH1, has been contested. The field has been waiting for a cleaner case. In February 2026, a paper landed in Science claiming to deliver one. Lead author Kishalay Day at Columbia. Title: Disappearance of a massive star in the Andromeda Galaxy due to formation of a black hole. Peer-reviewed. The strongest observational case for a quiet collapse to a black hole that anyone has ever published. The star is M31-2014-DS1. A hydrogen-depleted supergiant, about 20 times the mass of the Sun. It sits in the Andromeda Galaxy, the spiral next door, 2.5 million light-years out. Here is what happened to it. In 2014, the star brightened in mid-infrared light. A moderate outburst, not a supernova, but something. Around 2016, it started to fade. By 2022 and 2023, it was essentially gone in visible and near-infrared, about 1/10,000th of its original optical brightness. A faint mid-infrared glow remained, consistent with leftover heated dust around whatever was left. No supernova was ever recorded at that location. Not a flicker, not an alert. The brightening, the fade, and the disappearance played out over 9 years. The only reason we know about any of it is that an infrared telescope was patiently watching the sky on its own time. That telescope is NASA's NEOWISE, the Infrared Sky Survey extension of WISE, retired in 2024 after 11 years on orbit. Every 6 months, NEOWISE scanned the whole sky in infrared and dropped the data into a public archive. Day's team went back through that archive and pulled the light curve. Then they layered on follow-up data from JWST, Hubble, the Keck telescope, the Chandra X-ray Observatory, Palomar's Zwicky Transient Facility, and the Large Binocular Telescope. A multi-decade, multi-instrument stack converging on 1 pixel in Andromeda. And here is the picture that came out the other end. A star that brightened, faded, and vanished, with no supernova, and no luminous X-ray accretion disk where it used to sit. Chandra looked, and there is nothing bright eating material in that spot. Exactly what you would expect if a black hole had quietly formed and the leftover dust had mostly fallen back in without lighting up. If Day and the team are right, this is what a massive star turning into a black hole looks like when nobody is supposed to see it. Except, and this is the part the headlines tend to skip, the field is not settled. The 2026 literature on this single star is already arguing with itself. Within weeks of the science paper, 2 more papers dropped on archive. The first, from Beasor and colleagues, backed up the failed supernova interpretation. Fresh JWST observations, persistent dust-enshrouded source where the star used to be, consistent with quiet collapse. The second paper, and the title is real, this is the actual title, was called The Failed Supernova Scenario of M31-2014-DS1. That paper argues the 2014 brightening was actually a luminous red nova, which is what astronomers call it when 2 stars in a binary spiral together and merge. The disappearance in this reading isn't a star turning into a black hole. It is the merged remnant hiding behind a shell of dust the merger threw off. Both papers are from 2026. Both teams are good. Both interpretations fit a chunk of the data. The community has not picked a winner. The 2 readings answer completely different questions. If Day is right, humans now have the cleanest observational record of a massive star turning into a black hole without exploding. The textbook case for the next generation. Strong evidence that a meaningful fraction of massive stars die this way. If the merger paper is right, the phenomenon is still real in theory, but the cleanest example just got demoted and the search continues. For now, the strongest candidate we have is being challenged in real time. And the answer matters for how often the universe makes black holes quietly. Step back for a moment, because the meta-story here is almost as interesting as the star. This finding took 10 years to surface. The brightening happened in 2014. The disappearance was complete by 2023. The paper landed in 2026. The reason it took that long is that nobody knew to look. The data was sitting in an archive, waiting for somebody to ask the right question of it. That is about to change. The Vera Rubin Observatory in Chile had its first light in 2025. Its survey, the Legacy Survey of Space and Time, scans the entire visible southern sky every few nights. It is built specifically to catch transients, things that brighten, fade, or vanish in close to real time. The Roman Space Telescope, planned for 2027, adds an infrared layer. The next failed supernova won't take a decade to confirm. It will be a press release within weeks of the event. Which means, if the failed supernova interpretation of M31-2014-DS1 holds up, this is the last one of these we'll ever have to find in the rearview mirror. We don't know yet whether M31-2014-DS1 is the cleanest case of direct collapse on record, or a stellar merger in disguise. 2 papers, same year, same star, opposite conclusions. The answer comes from more observations, more time, and probably a couple more candidates. What is not contested is the underlying claim. The red supergiant problem is real. Massive stars are going missing from the supernova count, and the math says they're going somewhere. The leading explanation, a meaningful fraction of them, somewhere between 1 in 6 and 1 in 3, collapse into black holes without ever announcing it. Every massive star you can see in the night sky right now will eventually die. We have been assuming we know how. We might be wrong about a sizable percentage of them. The universe might be quietly making black holes that nobody sees form. That is one of those facts worth pausing on. Somewhere out there in the dark, the universe is making black holes without telling anyone. We are just learning how to listen. The next thing to watch is whether the Rubin Observatory catches one of these in real time. When it does, the case for quiet collapse goes from one disputed star to a population. The channel will be there. If you would like to be too,